In 11 days, I watched 1,437 stars disappear from the southern deep field. I don't mean variable stars dimming below detection threshold. I don't mean occultation events or equipment drift. I mean stars that had been cataloged, confirmed, spectrally classified, and observed continuously for decades. Gone. Between March 3rd and March 14th, 2031, sector by sector. In a pattern I didn't recognize at first. The catalog still listed them. They were supposed to be there. But when I pointed the array at those coordinates, there was nothing, just dark, the kind of dark that doesn't even scatter. I filed 17 anomaly reports in those 11 days. Mission Control in Houston acknowledged each one. They sent back calibration protocols. I'd already run the calibration protocols. I'd run them twice. The equipment was fine. The sky was wrong. Shackleton Deep Field Observatory sits at the bottom of a crater at the lunar South Pole. Not inside the crater, in the wall of it. The habitat modules were drilled into the regolith and rock at a depth of 2.8 kilometers, connected to the surface by a pressurized elevator shaft that took 11 minutes to travel one way. The telescope array sat on the crater rim, in direct line of sight to the southern sky. The crater floor, the actual bottom, another 4 kilometers below us, hadn't seen sunlight in over 2 billion years. The temperature down there held steady at minus 233 degrees Celsius. We didn't go to the crater floor. Nobody did. There was nothing there. That was the point. Shackleton was chosen because the permanent shadow meant zero light contamination. The coldest, darkest, most electromagnetically quiet place humans had ever built anything. Perfect conditions for deep field observation. Terrible conditions for everything else. The habitat was 4 connected modules: observation lab, crew quarters, galley and medical, and systems engineering. Standard ESA deep installation layout. The corridors were narrow, the ceilings low, and every surface was the same institutional gray that someone in procurement had decided was calming. It was not calming. It was the color of a headache. The lighting was fluorescent tube panels recessed into the ceiling. About a third of them were dead or dying at any given time. Requisition forms for replacement tubes took 8 weeks to process. I stopped filing them after month 2 and learned to navigate by the working lights. The crew was 4. Dr. Rourke, station commander, geophysicist by training, bureaucrat by disposition. Chen, systems engineer, kept everything running, rarely spoke, excellent at cards. Kowalski, telecommunications and data relay, responsible for our uplink to Houston, a talker, the kind of person who narrated his own actions out loud. And me, Solvik, astrophysics, deep field observation. My job was to point the telescopes at the oldest light in the universe and write down what I saw. For 14 months, that is exactly what I did. Shackleton was quiet. That was the word everyone used. Quiet. The kind of quiet that starts in your ears and moves inward until it lives in the center of your chest. The station hummed, recyclers, thermal regulators, the circulation fans that pushed the same air through the same filters and back through our lungs. And after a few weeks, you stopped hearing it. The hum became part of your own biology, something your body produced. I noticed it only when it changed. And for the first 9 months, it didn't change. The southern deep field from Shackleton is the cleanest optical window humans have ever had into the early universe. No atmosphere, no light pollution, no electromagnetic interference from civilization. The array could resolve objects that ground-based telescopes couldn't confirm existed. I spent most of my waking hours in the observation lab, cross-referencing catalog data with live feeds, looking for transient events, spectral anomalies, anything that the automated systems might flag for human review. Most of it was routine, stars doing what stars do. But the routine was the point. I wasn't looking for anything extraordinary. I was building a census, counting the lights, confirming they were where they were supposed to be. It was meditative in a way. The oldest photons in the observable universe, collected by mirrors on the rim of a crater on the moon, fed through processing software and displayed on a monitor that buzzed at 60 hertz, interpreted by a woman who drank too much coffee and hadn't spoken to her mother in 11 months. The scale of it would hit me sometimes, usually late in the station's night cycle, when the corridors were empty and the only light was the monitors and the only sound was the hum. I'd look at the data and understand briefly that the light I was cataloging had been traveling for 12 billion years before it touched our telescope, that it had left its source before Earth existed, before the sun ignited, that I was the first consciousness in the history of the universe to observe it. Then the moment would pass, and I would log the entry and move to the next coordinate. Kowalski was the night owl. I'd hear him in the corridors during the late hours, pacing. He said he couldn't sleep. The quiet got into his head, he told me once. Not the noise quiet, the distance quiet. He said he could feel how far away everything was. Earth was 384,000 kilometers in a straight line. The nearest supply shuttle was a 6-week round trip. The nearest star in my catalog was 4.2 light years. He said the numbers sat in his skull like stones. I told him that was poetic. He didn't laugh. There was one thing I couldn't explain. Telescope 7, the far infrared array on the eastern rim, had been flagging a thermal anomaly since week 6. A faint infrared excess in a sector of the deep field where no infrared source should exist. Not a star, not reflected light, not instrument noise. I checked. Chen checked the hardware. Clean. Kowalski checked the data relay. Clean. The anomaly was real. A whisper of warmth in a place that should have been as cold as the vacuum itself. I logged it, filed it, put it in the weekly report. Houston acknowledged receipt. No follow-up. These things happen, they said. Background fluctuation, calibration residuals. I accepted that. At the time. There was another thing, the maintenance shaft. A narrow service tunnel running from the habitat's lowest level down to the thermal regulation systems and the station's foundation anchors. It hadn't been accessed in 2 years, according to the official logs. Sealed off after a routine inspection found nothing worth inspecting. But 3 months into my rotation, I noticed the access logs for the shaft's hatch showed entries. Time-stamped at 0200, 0347, 0418. Hours when no one was scheduled. No one was supposed to be awake. I asked Rourke about it. He said the logging system glitched sometimes. I asked Chen. He said the same thing. Kowalski was the only one who didn't have an answer. He just looked at me for a moment too long before changing the subject. March 3rd, 2031. I opened the Southern Deep Field catalog to begin my weekly comparison run and found a discrepancy. Sector 7741 South, a dense field I'd been tracking since month 1. The previous week's observation showed 4,112 cataloged objects in that sector. The current count was 4,096, 16 stars missing. I assumed equipment error, ran the calibration suite, ran it again, pointed a second telescope at the same sector for independent confirmation. The second telescope agreed. 4,096. I checked the archival data from the previous 6 months. The count had been 4,112 every single week, within a margin of 3 for atmospheric variables that don't exist on the moon. Steady, consistent, and now 16 objects gone. I filed the first anomaly report at 0600. Houston confirmed receipt at 0814. They requested I run the standard differential photometry protocol. I'd already run it. I ran it again. The results were the same. 16 confirmed stellar objects, ranging from magnitude 14 to magnitude 19, were no longer emitting detectable photons in any wavelength from radio to gamma. Not variable. Not occluded by a transiting body. Not redshifted beyond detection limits. Just absent. As if someone had reached into the sky and turned them off. I remember the exact thought I had. Sitting there in the observation lab, 0900, holding a printout of the differential analysis, still warm from the printer. I thought, stars don't just stop. That's not how any of this works. A star is a sustained nuclear reaction. It doesn't pause. It doesn't go dark without a reason, without a collapse, a detonation, a process that would leave an observable signature. These stars left nothing, no remnant, no afterglow, no expanding shell of debris. The photons simply stopped arriving, as if the source had been removed. March 5th, 41 more gone, same region. Adjacent sectors this time, 7741 and 7742, the boundary between them. The disappearances weren't random. They clustered. I pulled up the spatial distribution and plotted each missing object on a grid. The pattern was immediately obvious. They were disappearing from the center outward, a growing dark patch in the middle of the field, expanding in every direction. But not uniformly. The expansion was faster in some directions than others. I overlaid a radial analysis. The rate of expansion was highest along a curved path that swept from the lower left of the sector toward the upper right, then back down, then out again. Not a straight line, not a circle. It spiraled. On March 8th, I was in the observation lab at 0300. I'd stopped keeping regular hours by then, and I watched it happen in real time. A star I'd been observing for 7 months, catalog number S, F77412884, a stable G-type main sequence about 12 billion years old. I had it centered on the primary monitor, spectral feed running live. At 0317, the signal dropped. Not gradually, not over seconds or minutes. One frame it was there, a healthy, unremarkable star doing exactly what it had done for 12 billion years. The next frame, nothing. The monitor showed empty coordinates. The spectrograph flatlined. I sat there for 40 minutes, watching the empty coordinates, waiting for the star to come back. It did not come back. I filed anomaly report number 9. Houston acknowledged receipt. They asked if I'd considered the possibility of a software error in the catalog numbering system. I had not considered that possibility because it was not a software error. I knew that. They did not. March 11th. The count in sectors 7,741 and 7,742 had dropped by 340 stars. The dark region on my plot was now visible to the naked eye on the telescope feed. A patch of sky slightly darker than the surrounding field, like a thumbprint on a window. Except this window was 12 billion light years deep, and the thumbprint was growing. I sent a priority flag to Houston requesting a formal investigation. Mission Control assigned the request to the Deep Field Anomaly Review Queue. Estimated review time, 12 weeks. 12 weeks. I did the math on the rate of expansion. In 12 weeks at the current rate, the dark region would have consumed an estimated 6,000 stars from the catalog. I sent the math to Houston. They thanked me for my diligence and reminded me to continue following standard reporting protocols. Chen came into the observation lab that evening and looked at my plot. The spiral of missing stars pinned to the corkboard, red dots on black paper, the dark center growing day by day. He studied it for a long time. Then he said something I've never forgotten. He said, "That looks like it's moving." I told him it was. The disappearances were progressing outward from a central point, spiraling. He shook his head. He said, "No, not outward. It looks like something is swimming." The word Chen used changed something in my head. Swimming. Once he said it, I couldn't unsee it. The spiral pattern wasn't expanding like a shockwave. Uniformly, mechanically, it was progressing the way a living thing moves through a medium. The leading edge advanced, the trailing edge followed, and the whole structure rotated as it went. Like a corkscrew. Like something threading itself through the fabric of the sky. I didn't say that to Houston. I didn't say it to anyone. Because the implication was not something I was ready to think about. And the moment I spoke it out loud, it would become real. Instead, I doubled down on the data. If this was a natural phenomenon, a dust cloud, a gravitational lens, some kind of mass extinction event in a distant galaxy, the data would show it. There would be a signature, an explanation that fit inside the laws of physics, as I understood them. I worked 18-hour days for the next week. I barely ate. Rourke told me I was obsessing. He said the anomaly was interesting but not urgent, and that I should maintain a regular schedule for my own health. He said this while standing in the doorway of the observation lab, backlit by the corridor fluorescence, not entering the room, not looking at the data. Rourke had stopped looking at my data sometime around anomaly report number 6. Kowalski, on the other hand, was looking at it too much. I'd come into the observation lab at odd hours and find him there, standing behind my chair reading my terminal. He never touched anything, never sat down, just stood there, reading, with an expression I couldn't categorize. When I asked him what he was doing, he said he couldn't sleep. When I asked why, he said the quiet was louder now. I didn't know what that meant. I do now. March 12th. I ran an angular diameter calculation on the dark region, using the rate of expansion and the distance to the background stars as a baseline. The math was straightforward. I'd done hundreds of these calculations for other phenomena. Angular size on the sky, known distance to background objects, solve for physical size at various intervening distances. The results didn't make sense. If the dark region was at the distance of the background stars, 12 billion light-years, then whatever was blocking the light was larger than any structure ever observed. Larger than galactic superclusters. That was clearly impossible. So it wasn't at the distance of the background stars, it was closer. I ran the calculation for 10 billion light-years, still impossibly large. 1 billion. Still too large to be any known object. 100 million, 10 million, 1 million. The numbers kept coming back wrong. Too big. Too big at every distance, unless it was very close. I ran the calculation for 1 light-year. The object, or region, or whatever it was, would be roughly the diameter of Neptune's orbit. That was enormous. But it was within the bounds of known natural phenomena. A rogue molecular cloud, perhaps. Dark matter concentration. Something massive but inert, drifting between the stars. I felt a rush of relief. There was a rational explanation. Something big but explicable had drifted into the line of sight between our telescopes and the southern deep field. It was blocking background stars the way your hand blocks sunlight. Simple geometry. Simple physics. I ran the thermal correlation. If a massive cold object was between us and the deep field, Telescope 7's thermal sensors should detect it, or more accurately, should detect the shadow it cast in the cosmic microwave background. I pulled Telescope 7's thermal data from the past 9 months and overlaid it against the star disappearance timeline. The thermal anomaly, the one I'd logged in week 6, the one Houston called calibration residuals, lined up perfectly. The infrared excess appeared in the same sector, at the same time, tracking the same position as the center of the dark region. It had been there since before the stars started disappearing. Whatever this thing was, it had been there the whole time. We just hadn't been looking for it. I should have felt vindicated. The data supported a coherent model. Natural object, large, cold, drifting in the interstellar medium, blocking background starlight. Publishable, significant, career-defining possibly, but I didn't feel vindicated, because the thermal data showed something else. The infrared signal from Telescope 7 wasn't constant. It was changing. Not in intensity, in angle. The thermal source was shifting position relative to the background stars. It was moving, and it was moving toward us. I ran the parallax calculation twice, 3 times. The object, whatever it was, wasn't at interstellar distances. It wasn't even at 1 light-year. The parallax shift over 9 months of observation put it inside the solar system. Well, inside, somewhere between the orbits of Jupiter and Saturn, based on the convergence of the angular data, moving inward, toward the sun, toward us. Kowalski found me in the observation lab at 0400 on March 13th. I hadn't slept. The calculations were spread across 3 monitors in the desk and the floor. He didn't ask what I'd found. He looked at the numbers for a long time and then he said, "I know." He said he'd felt it getting closer. I asked him what he meant. He said the quiet had a direction now. March 14th. 0600, I built the model. I'd been avoiding it. Some part of my brain knew what the model would show, and that part had been finding reasons not to build it. Equipment checks, calibration runs, meals I didn't taste. Anything to postpone the moment when the data stopped being numbers on a screen and became a shape in 3-dimensional space. But on the morning of March 14th, I had no postponements left. I loaded 9 months of star disappearance data, thermal readings from Telescope 7, parallax measurements, and angular expansion rates into the spatial modeling software, and pressed render. The model built itself in 11 seconds. 11 seconds to reshape everything I understood about the universe I lived in. The star disappearances were not a patch on the sky. They were not a two-dimensional region of darkness on a flat projection. The model showed depth. The dark region had three-dimensional structure. It was an object, a volume, an actual physical thing hanging in space between the array and the background stars. And it was casting a shadow on the deep field, the way a stone casts a shadow on the riverbed when you hold it up to the light. I rotated the model. The shape was irregular, not spherical, not elliptical. It was elongated, segmented. The leading edge tapered to a blunt point. The trailing end extended beyond the boundaries of my data. I couldn't see where it ended. The spiral pattern of star disappearances wasn't the object's shape. It was the object's motion. It was rotating slowly as it moved, corkscrewing through space, swimming. Chen's word, swimming. The model estimated its nearest approach distance at roughly 2 astronomical units, twice the Earth-to-Sun distance. Close. Cosmically speaking, intimate. And it was still getting closer. I sat in the observation lab and stared at the wireframe model rotating on my monitor, and I understood something that I have never been able to fully articulate in the 7 years since. The thing I was looking at was not a natural formation. It was not a rogue planet. It was not a molecular cloud, or a dark matter structure, or anything that fit inside any model I'd spent a career building. The shape was wrong. The segmentation was wrong. The rotation was wrong. Natural objects in space do not corkscrew. They spin on axes. They tumble. They orbit. They do not swim. What I was looking at, what had been drifting through our solar system for at least 9 months, probably longer, undetected by every survey and telescope on and around Earth, was a body, an organism, something alive, something so large that its passing blocked the light of over 1,000 stars, and it was heading inward, toward the sun, toward us. I printed the model. I pinned it to the corkboard next to the spiral plot. I sat down. I think I was there for a long time. Kowalski found me. He looked at the printout. He didn't speak for a while. Then he said, "How long until it gets here?" I said I didn't know where here was. It was already here. It was inside the solar system. It was closer than Saturn. He asked, "Can it see us?" I said it didn't have eyes. He said, "That's not what I asked." I decided to go up. I needed to look at the sky, not through the telescope feed, not through the monitors, not through the layers of processing and false color rendering that turned raw photons into digestible data. I needed to stand on the surface and look up with my own eyes and see the place where the stars were missing. Rourke argued against it. He said an EVA was unnecessary, that the telescope data was sufficient, that I was sleep-deprived and irrational, and that he was entering a formal concern about my psychological state into the station log. I told him to enter whatever he wanted. I was going up. Chen prepped my suit. He didn't argue. He didn't ask why. He just ran the checklist and sealed the joints and checked the oxygen twice. Before I stepped into the elevator, he said something I didn't expect. He said, "Don't look at it for too long." I asked him what he meant. He said, "I don't know. Just don't." The elevator took 11 minutes. I stood in the pressurized chamber and felt the vibration of the motor through my boots and listened to my own breathing inside the helmet and counted the seconds. 660 of them. Each one a meter of rock passing between me and the surface. Between me and the sky. Between me and whatever was up there. The airlock cycled. The outer door opened. I stepped onto the surface of the moon, and the universe opened above me like a wound. The southern sky from the rim of Shackleton Crater is not something I can describe adequately. No atmosphere to filter, no city light to wash it out, no clouds. Just the raw face of the cosmos, More stars than your visual cortex can process. A density of light that should be overwhelming, but isn't because each point is so precise, so sharp, so impossibly far away, that the overall effect is not brightness, but depth. You don't look at the sky from Shackleton. You look into it. You can feel the distance. The 12 billion light years between your visor and the edge of the observable universe. Your body knows it's there, the way you know the depth of the ocean when you swim above it. That vertigo, that thinning of the self. I walked to the telescope array. The pylons were skeletal against the star field, their shadows knife-sharp in the unfiltered sunlight that struck the rim's eastern edge. I moved through the shadows and the light, through the pools of black and the slashes of white. No transition, no gradient, just binary. Light, void. I reached telescope 7. The housing was standard. A reinforced casing protecting the optical assembly, thermal sensors on a secondary bracket, data cables running along the regolith to the relay hub. Nothing unusual, nothing visibly wrong. The thermal sensors showed the same anomalous reading they'd shown for 9 months. I accessed the telescope's local feed on my suit display. The deep field appeared on the visor HUD, a small window showing the sector I'd been watching for 11 days. And there it was, the dark patch, visible now without enhancement. A region of the sky where stars should be and were not. Not cloud dark, not shadow dark. An absence of light so complete that it looked like a hole, like someone had cut a piece out of the sky and left nothing behind. I toggled off the suit HUD and looked up with my naked eyes. I could see it. Standing on the rim of Shackleton Crater, 2,800 kilometers from the habitat below, surrounded by silence so total it had physical weight, I could see the place where the stars ended. It was larger than I'd calculated. The dark region covered maybe 15 degrees of the sky, 30 times the diameter of the full moon, if I'd been standing on Earth. A patch of absolute nothing, bordered by the sharp, hard, unblinking points of the surrounding star field. And it was not the same shape as last week. The leading edge had advanced. The trailing edge had followed. The whole region had moved, visibly, against the background stars. I stood there and watched. Minutes passed. The silence was so complete that I could hear my own blood moving through my veins. The suit's thermal readout climbed. Not my core temperature, the external sensor. The ambient temperature on the surface was registering minus 189 Celsius. It should have been minus 233. Something was radiating heat into the vacuum. Something close. I switched the telescope feed to maximum gain and pointed it at the leading edge of the dark region. Maximum magnification. Full infrared overlay. Every sensor telescope 7 had, trained on the border between the starlight and the void, the suit display filled with data. And in the data, in the processed, enhanced, false color translation of raw photons, I saw something. At the edge of the dark region, where the last stars still shone before the nothing began, there was texture. Not the smooth, featureless black I'd expected. The enhanced feed showed surface detail within the darkness. Ridges. Deep, parallel ridges running along the length of the dark region, curving gently, like the segments of an insect's abdomen scaled to a size that made my brain physically resist processing it. The ridges were pale, not white. The color of bone left in deep water. Each ridge was pitted and cratered with age, not impact craters, but the kind of erosion you see on things that have been exposed to the elements for geological time periods. Except there are no elements in deep space. No wind, no water, no erosion. Whatever had weathered this surface operated on a scale and over a time period that I could not estimate. Between the ridges, in the valleys where one segment met the next, I saw something else. A faint glow, blue-green, pulsing slowly, not reflected starlight. This was generated, bioluminescence. The rhythm was wrong, not a heartbeat, not breathing, something slower, a cycle measured in minutes, maybe hours. The glow illuminated the texture from within, turning the pale surface faintly translucent in patches, and through those patches, I could see deeper structures. darker shapes moving beneath the surface, the way you can see veins through thin skin held up to light. What I was looking at was not a formation, not a cloud, not a structure. It was a surface, the surface of a body, a living body that was so large it blocked the light of stars. I was looking at its skin. I increased magnification. The suit display struggled. The resolution couldn't hold. VHS tracking lines tore across the image. The color bled. Static bursts interrupted the feed. But between the bursts, between the moments of corruption, I caught details. Barnacle-like growths clustered along the ridges. Mineral deposits, or something that resembled mineral deposits, crusted in patterns that suggested they'd been accumulating for millions of years. A texture that was simultaneously organic and geological. Living tissue that had become, through sheer age, indistinguishable from stone. I panned the telescope along the body. Each segment was larger than the one before. The ridges deepened. The bioluminescent glow intensified. I followed the body toward what I assumed was the head, the leading edge, the tapered point of the wireframe model. And then the telescope reached the limits of its lateral range, and the body continued. I was looking at a small fraction of this thing. A window. A peephole. The leading edge was outside my field of view to the left. The trailing body extended beyond my field of view to the right. I was standing on the moon, looking through the most powerful telescope array humanity had ever built, and I could not see the whole organism. Each segment that I could see was the size of, I don't have a good comparison, cities, small countries, small, things that are supposed to describe geography, not biology. The suit's external thermal sensor was climbing, minus 180, minus 170. The body heat of the organism was reaching the lunar surface from a distance of approximately 2 astronomical units, 300 million kilometers, and I could feel its warmth on my suit sensors. The ground beneath my boots vibrated. Not a tremor, a resonance, something deep and slow, like the lowest note of an organ playing in a cathedral the size of the solar system. The vibration traveled through the regolith and up through the suit's boots and into my skeleton. I felt it in my teeth, in my sternum, in the part of the spine where the body keeps its oldest fears. I stood on the rim of Shackleton Crater, and I understood, with a clarity that felt like something breaking inside me, that I was not looking at a discovery. I was not the scientist who found the thing that changed our understanding of the universe. I was an insect, standing on a grain of sand, watching something pass overhead that did not know I existed, could not know, would never know, because knowing would require it to perceive at a scale so small that I was below the threshold of its reality, the way a bacterium is below the threshold of yours. And this organism, this ancient, segmented, patient thing, was passing through our solar system the way a whale passes through a cloud of plankton, not hunting, not consuming, just moving, just following a path it had followed since before this star ignited. And the stars weren't being eaten. They weren't being extinguished. They were being eclipsed, temporarily. As it passed between us and them, they would return after it moved on. Some of them already had. I checked the earliest disappearance sectors and confirmed stars that had vanished in the first days were reappearing at the trailing edge as the organism moved past them. The stars were fine. They had always been fine. It was us. We were the ones in its path. The vibration intensified. The thermal readings spiked. Minus 130. Minus 110. The surface temperature of the moon at the South Pole was climbing toward levels that should have been impossible. The organism was getting closer. Or, a worse thought, a different part of it was getting closer. A larger part. A segment I hadn't seen. I looked up from the suit display, looked at the sky with my own eyes, and I watched the stars go out. Not on a monitor, not in a data feed, with my own eyes. From left to right across the southern sky, stars winked out, one by one, then in clusters, then in sweeping arcs as the edge of the organism's body crossed my line of sight. The star field collapsed. 1/4 of the visible sky went dark. The remaining stars seemed to crowd together, huddling at the edges of the growing void. And in the void, at the very edge of what my eyes could resolve, I saw the glow, faint, blue-green, pulsing, through the surface, through the skin of something so vast that 1/4 of the sky was its silhouette. My suit alarm went off. Not the thermal warning, a different alarm, electromagnetic interference. The suit's navigation systems were failing. The compass was spinning. The HUD flickered, glitched, and displayed numbers that weren't possible. The ground vibration peaked. I dropped to my knees, not by choice. My legs simply stopped supporting me. I knelt on the regolith on the rim of the darkest crater on the moon and looked up at a sky that was no longer full of stars, and I understood that everything I knew, everything humanity knew, about our place in this universe was wrong. We were not explorers at the frontier of knowledge. We were not the curious species reaching outward into the cosmos. We were organisms on a rock, orbiting a minor star, in the path of something so ancient and so large that our entire civilization was a rounding error in its existence. The organism did not see me. It did not react to my presence. It did not slow or turn or notice in any way that a living thing stood on the surface below it and looked up. It simply continued, patient, unhurried, following a trajectory older than the fossil record of Earth. And then, slowly, over the course of 20 minutes that felt like 20 years, the stars began coming back. From the left, where the leading edge had passed first, pinpoints of light returned, one by one. Then, in clusters. The sky rebuilt itself from the edge of the void, star by star, as the organism's body moved past and the background light re-emerged. The dark region shifted to the right, shrank. The thermal readings began falling. The vibration faded from my bones. The stars that had been eclipsed reappeared, unchanged, 12 billion years old, as if nothing had happened, as if nothing had passed between us and them. I stayed on the surface for a long time after the stars came back. The temperature dropped to -210, -220. Normal. The electromagnetic interference cleared. My suit system stabilized. I stood up. I turned around. The telescope pylons were still there. The habitat was still there, 2,800 meters below my feet. Earth was visible above the crater rim, a half circle of blue-white, small, fragile, completely unaware of what had just passed through its sky. I took the elevator back down. 11 minutes, 660 seconds. I counted everyone. The others knew something had happened. I came back through the airlock and Chen was standing there. He'd been watching my suit telemetry from the systems bay. He'd seen the thermal spike, the electromagnetic interference. The moment my suit stopped transmitting for 43 seconds during the peak. He asked me what happened up there. I told him. All of it. He sat down on the airlock bench and didn't speak for 10 minutes. Then he asked me to show him the telescope feed. We went to the observation lab. I pulled up the recording from Telescope 7, the raw feed from the encounter, the enhanced imagery showing the surface texture, the ridges, the bioluminescence. I showed him the angular calculations, the 3D model, the parallax data. I showed him the reappearance of stars at the trailing edge, confirming the eclipsing model. He watched everything, twice. Then he said, "This doesn't leave the station, not yet." I asked why. He said because Houston will shut us down. He was right. I knew he was right. A crew of 4 on the moon reporting a living organism larger than planetary orbits passing through the inner solar system. We would be pulled within a week. Psychological evaluation. Medical review. The data would be quarantined. The observation program would be suspended. And no one would look at the sky until it was too late to see anything. So I did something I'm not proud of. I filed Anomaly Report number 18. It described a significant calibration event in the telescope array requiring manual surface inspection. It noted the thermal anomaly had been identified as a hardware degradation issue in Telescope 7's secondary sensor bracket. It recommended continued monitoring. I did not mention the organism. I did not mention the encounter. I did not mention the stars going out. I buried it. And then I spent the next 3 weeks collecting every piece of data I could, every observation, every thermal reading, every parallax measurement, every frame of telescope footage, and I backed it up to personal storage drives. 3 copies. One stayed in my quarters, one went to Chen, one I sealed in a maintenance compartment that I knew Rourke never checked, because I knew what was coming. On April 2nd, Houston notified us that Shackleton Observatory was being decommissioned. Budget reallocation. The Deep Field Observation Program was being transferred to the James Webb successor platform. The crew was scheduled for extraction on April 15th. Rourke accepted the order without question. Kowalski seemed relieved. Chen and I packed the data drives and said nothing. The shuttle came. We left the moon. I watched Shackleton Crater recede through the viewport, the telescope pylons, the habitat access hatch, the rim where I'd knelt and watched the sky go dark. It got smaller. The crater became a divot. The moon became a sphere. Earth grew in the viewport, blue and white and small. We docked at Lagrange Station and transferred to an Earth return vehicle, and nobody asked me about the stars. They gave me a desk in Darmstadt, ESA headquarters, a windowless office on the 4th floor of a building that hummed with servers and climate control and the sounds of people doing ordinary work. My title was Senior Analyst, Deep Field Data Review. My job was to process historical observation data from decommissioned programs. I was very good at it. No one asked about Shackleton. The decommission report listed the reason as budgetary reallocation, and budgetary reallocation is a phrase that stops all conversation. I submitted the telescope data from my personal drives to the ESA archive. All of it. The star disappearance timeline, the thermal anomaly correlation, the parallax calculations, the 3D model, the telescope footage from the encounter. I submitted it with a formal analysis paper recommending immediate follow-up observation of the southern deep field using the James Webb successor. The paper was reviewed. The review took 4 months. The review board returned a finding of inconclusive and recommended no further action. The thermal anomaly was attributed to sensor degradation. The star disappearances were attributed to a systematic catalog error. The telescope footage was classified as recording artifacts consistent with VHS medium degradation in a high radiation environment. The 3D model was described as an interpolation artifact of insufficient data points. Every piece of evidence individually had a plausible alternative explanation. That was the thing. No single data point was proof. The thermal anomaly could have been hardware. The star disappearances could have been catalog errors. The footage could have been VHS corruption. Each explanation was unlikely but not impossible, and the review board, faced with the choice between unlikely but possible mundane explanations and the alternative, that a living organism larger than planetary orbits was transiting the inner solar system, chose the mundane, every time. I don't blame them. I would have done the same. Chen left ESA 6 months after we returned, moved to the private sector. We don't talk about Shackleton. Kowalski transferred to a ground-based facility in Chile. I heard from a colleague that he still doesn't sleep well. Rourke retired, published a memoir about his career in space that doesn't mention the telescope anomaly. The observation lab at Shackleton sits powered down in a crater on the moon, 2,800 meters below the surface, in permanent darkness, with a corkboard on the wall that still has a spiral of red dots pinned to black paper. Nobody will see it again. 7 years now. Every Monday morning, before my first coffee. Before I open my email, I pull up the Public Stellar Catalog database and I run a count on the southern deep field sectors. 7,741, 7,742, 7,743. All the sectors in my original observation window. The count changes. Not every week, not dramatically, but it changes. 30 stars missing 1 month, 50 the next. Then a period of stability, then another drop. The pattern isn't random. I've plotted it. It spirals, the same motion, the same trajectory, the same patient, corkscrewing path through the field. The organism is still there, or it came back, or it never left. I don't know. The data doesn't tell me where it is, only where it's been. The shadow it casts on the sky as it passes between us and the oldest light in the universe. Sometimes, on clear nights, I drive out of Darmstadt to the countryside where the light pollution thins, and I look up. I look south. I can't see the individual stars of the deep field. You need a telescope for that. But I can see the sky, the Milky Way, the dense band of our galaxy arcing overhead, and I wonder if there are gaps in it that weren't there before. Spaces between the stars that are a little wider, a little emptier, a little darker than they should be. I wonder if it's getting closer. I wonder if the next transit will bring it inside Earth's orbit, inside the orbit of the moon. I wonder what the thermal readings would look like then, what the ground would feel like, whether anyone would notice before it was too late. The data says the organism moves slowly, patient. Its orbital period, if you can call it an orbit, takes centuries, maybe millennia. It may not pass this close again in my lifetime, or it may pass closer tomorrow. I don't know. The data doesn't tell me that either. What the data tells me, what it has told me every Monday morning for 7 years, is that the star count in the southern deep field is lower than it was when I started watching, and it keeps getting lower. Slowly, steadily. The way a number drops when something large is moving through it. The way a population declines when something is feeding. I don't think it's feeding. I think it's just passing through. I think the stars are fine. They come back after it moves past them. They always come back. But there's a voice in my head, the same voice that told me the spiral was moving, the same voice that told me the thermal anomaly was real. And that voice says, what if they don't all come back? What if some of them stay dark? What if the organism isn't just eclipsing the stars? What if it's changing them? I don't have evidence for that. It's not in the data. It's just a feeling. The kind of feeling you get when you've looked at something too big to understand, and the part of your brain that should be afraid has gone quiet, because fear is a response designed for threats you can survive. And this isn't that. This is something else. Something older than fear. The knowledge that you are small, that you have always been small, that the universe was not built for you, and the things that move through it were not built to notice you, and the darkness between the stars is not empty. It was never empty. We just couldn't see what was in it. And now, on Monday mornings, in a windowless office in Darmstadt, I sit at my desk and I count the lights, and the lights keep going out.